So the next thing we should be able to do with radicals is rationalizing radicals. So when you see the word rational in any math context, rational always means that we're talking about a fraction. So when we're rationalizing radicals, it means there's a radical in the denominator of a fraction, and we don't want that. So rationalizing radicals means to get rid of radicals in the denominator. Rationalizing radicals means that we're trying to get rid of radicals in the denominator. So it's fairly easy. We're just going to only work with square roots on these, although you could have to rationalize if we had a different radical like a cube root, but we'll only see this if we have to do a square root. If there's just a single radical, it's actually pretty easy. Because we're trying to get a pair, we just have to multiply by the same radical that we're trying to get rid of. So on this one, our radical in the denominator is square root of 6. So if I'm trying to rationalize this one on A, I'm going to multiply. I have to multiply by the same radical in the denominator, square root of 6. Now, to not change my original number, I also have to multiply by square root of 6 in the numerator. Because if I'm multiplying by square root of 6 over square root of 6, I'm just multiplying by 1. So even though I'm going to change the way it looks, I'm not actually changing the number at all. So then to multiply fractions, we multiply the tops together. So on the top, I'd have 5 times square root of 6. We would just write that as 5 square root of 6 because the 5 is outside the radical and the 6 is under the radical. On the bottom, these are both under the radical, so square root of 6 times square root of 6. There's a couple ways you can think about that. You can actually multiply those together and have square root of 6 times 6, so square root of 36. Or you can also think of it, since it's square root of 6 times square root of 6, you can think of it as square root of 6 squared, since it's multiplying by itself. And we all know a square root and squared get rid of each other. So notice here on the top doesn't simplify. We have 5 square root of 6, but the bottom does. Square root of 36 is just 6. It's not under the radical anymore. So that would be our simplified answer. Notice it still has a radical in it, but the difference is the radical is not in the denominator. So that is the goal of rationalizing, is that we don't want any radicals in the denominator. Now, hopefully you've seen an example like this second one before in either Algebra 1 or Algebra 2. It's a little more tricky when there is two terms. So notice here on the bottom we have 4 plus square root of 2. I can't just multiply by square root of 2 because this is 4 plus square root of 2. So here's what we have to do when we have two terms. I am going to multiply by something like I did here. I'm going to multiply the denominator. What we're going to multiply by is called the conjugate. So here, if we have 4 plus square root of 2, the conjugate is 4 minus square root of 2. Okay, notice I put it in parentheses because I'm going to have to multiply it by this. So I'm going to have to use my distributive property or FOIL here. And since I multiply by 4 minus square root of 2 on the bottom, I also have to multiply by 4 minus square root of 2 on the top. So let's go ahead and multiply this out. So on the top, we're just multiplying 3 times this expression, 4 minus square root of 2. So I'm just going to distribute that 3. Again, that's another reason it's helpful to write with parentheses, is because that way we can remember to do all of our mathematics. And I'm multiplying not just the 4 by this number, but also the square root of 2. So if I distribute that, 3 times 4 is 12 minus, 3 times square root of 2, I would just write as 3 square root of 2. So that's what we have on the top. Now let's do the bottom. So I'm going to use this space here to multiply these together. You can also use box method. A lot of people prefer box method. Maybe that's what we'll go ahead and use here. So I'm multiplying 4 plus square root of 2 times 4 minus square root of 2. And that's going to give me 16 in this box. Here in this box, 4 times square root of 2. In this box, we'd have minus 4 square root of 2. And in this box, we'd have minus square root of 2 times square root of 2. We'd have minus square root of 4. Okay, so when we simplify, notice that the 4 square root of 2 and the minus 4 square root of 2 can add together. But because we have one positive and one negative, that's why it's important to use the conjugate. Those actually add up to 0. And if we look at this box, square root of 4 is a whole number, and it just simplifies to 2. So now I have a 16 and a negative 2. If I combine those, that would give me a 14 on the bottom. So now we can actually go ahead and leave our answer like this because nothing else will reduce or simplify. So 12 minus 3 square root of 2 over 14. Now, there still, again, is a radical. It's just not in the denominator anymore. Now, sometimes we can reduce. There's a couple ways to reduce this. Most of the time, we would just leave it like this, unless all the numbers that are not in a radical have a common factor, which they don't. But another way you can think of it, because this whole thing is over a 14, that means each term can be divided by 14, like that, 12 divided by 14 minus 3 square root of 2 divided by 14. The reason you might want to do that is only because then you could reduce this fraction, the 12 and the 14. The 3 and the 14 doesn't reduce. And we wouldn't reduce or change anything in the 2 because we can, just like we can only multiply things that are outside the radical, we can only divide or reduce things that are outside the radical together. But because all three terms, the 12, the 3, and the 14, don't have a common factor, we'd usually just leave it like this. All right, so that's what rationalizing looks like. So again, you're going to try a couple practice problems.